Great. Ladies and gentlemen, colleagues, we're again back. We want to look at something called wronskian. We see how this thing happens in this way. So we are having, in this case, we are supposing, suppose we have function is, can have y1 but a function of x, and y2 but a function of x. These ones can be solution is, in this case can be solution is to the dE of the differential. It can be solution to the differential equation. This is a differential equation. So if it is a differential equation, our differential equation can be in this format. Then plus we can have something like a. This is a function of x and y prime plus b. This is a function of x, y, and this is equal to 0. So we have something of this format. This is the equation, and we are saying that this one and this one are solution to this one. So what do we call wronskian in this case? Let us have some definition of wronskian. The definition of wronskian, the determinant of it is denoted by w. So if for us we are denoting it by w. Now our y1 and y2, this solution is here. They are determinants. The determinant is given by, we always have the determinant of this, then this is y2. Now we have to differentiate up to, but where are you supposed to? We shall have the differentiating in this case, and this y will give us the derivative, and this one also will give us the derivative. Now how can we know that we are supposed to end on this derivative? We always look at the order of the differential equation we are dealing with. In this case, you can see that our n is equal to 2. Now, to differentiate, we already differentiate up to n minus 1. So when you see that we already differentiate up to n minus 1, in this case, if n is 2, therefore you shall have differentiate up to n minus 1, and this one becomes 1. Therefore, you have to differentiate up to the first derivative, and you end there. Suppose our n was maybe equal to 3. You would have 3 minus 1, and this one could be such that you differentiate up the second derivative. Here we are only here as this wronskian. So we are saying that this determinant is the one we call the what? This determinant here is the one we call the wronskian. The one we call the wronskian in this case. So what happens is we can generalize this, and we can have that if y1, y2, up to maybe yn, a solution is to the differential equation. A solution to the differential equation, maybe it can be this one, n y prime n plus n minus 1, then this is yn minus 1 plus, you can go up to a n1 ny prime, then plus a naught y maybe equals 0. In that case, if this is the equation we are having, and these ones are all what solution is, in this case we say that in general our wronskian will be y1, y2, y3 up to yn, which must be given as the determinant of y1, y2, y3. You can go up to yn in that format. So what happens is we have to differentiate, but up to n minus 1. So we shall hand down 1, differentiate this, y2 differentiate this, you can continue up to y1, but you are differentiating it up to what? Up to n minus 1. In this case, that's what we are saying. So we have y2 prime, y2 prime, this is a prime, and then you have to go up to y, this is y2, but n minus 1. Have y3 prime, this is y3 prime, then you differentiate up to y3 n minus 1. So you can go this one, can continue, and also what will be here will continue. Then yn, the first derivative, n second derivative, then you go up to yn, but n minus what? 1. That's the differentiation, and this is the Wronskian in general. So how can we use it to solve differential equations? That concept we shall talk about it when we come back. For today, let us end with Wronskian. So when we come back, we shall talk about the concept of now how do we use the Wronskian to solve differential equations. For this time, I wish you the best.